In this chapter, chapter 4, we are talking about 3 important things. First, before we start, appreciate it. We need the graph. Thank you. When I say the graphs, I mean by graph for all of them. E, A, log, len, which they are just 4 graphs. The second, because actually graph 4 is very important, especially when you are studying something, growing bacteria, I don't know, whatever you have, statistic, something, depending, any graph, you need this, actually the exponential graph. The second that we need is identities. And actually identities will help you to solve equations. So we have exponential and logarithmic functions. The graph of them important, identities that we are going to take it is important, and equation 4.5 is important. So when you study, try to control all parts, especially graph and equations. Let me start with the first example. We have exponential. We have a to power x. Maybe I will ask you graph 2 to power 5. Study later, Kaka. I'll give you time. So maybe I'm going to ask you 2 to power 5. Okay? So how we find 2 to power 5? How we sketch 2 to power 5? 3 to power, which one of them? So you can see from here, that one needs calculator, cancel, because calculator not allowed. So I'm not going to give you the example like that. But try to learn how to find them, how to use your calculator. Maybe in the other lecture you need it. But here I'm going to focus on what? We are going to focus on the things that we need. I say graph this function or graph that function. We have 2 types of the graph. Look. If f of x, your function, is exponential function, any number, 2, 3, 4, 5, and go on. So the sketching the graph is like that. That one is the graph of 3 to power x, and that point is what? 0 and y. If x is 0, I'll get what? If I put x to be 0, y will be what? 1. Okay? So I'll get 0 and 1. X to power 0 is equal to 1. That's why. Good. Now this is the graph, the first graph for positive. If I give you during the exam, I say sketch 5 to power x, you can give me the same shape. The same shape. And you are going to write 0 and 1 again. Clear? Good. How about if I ask you to sketch that graph, 1 over 3 to power x, and you know that one, maybe I will ask you by the same other method. Do you think the first and the second are different? Yes? No. Just we put it here, we make it there, right? Clear? Both cases, the graph is like that. Careful. The graph is like that. So we have from right to left, or from left to right. So that one is the graph of 1 to power 3x. Again, the same point, right? If I put x to be 0, here's 0. Y will be what? 1 over 3 to power x to be 0. And y 1 over 1 is equal to 1. Clear, dears? So you have a shape, you have a point, nothing else. And look at the examples here in your lecture note. You can see here. And here's the first graph, second graph. How about if I change to something else? Look at here. All of them the same. All of them. 10 to power x, 5 to power x, 3 to power x, 2 to power x. But the intersection point are what? All are the same. So all of them have the shape like that. Do you have any question? During the exam, I don't say 2 to power x. I'll bring one of them. How about in the left side, if I give you 2 to power x, 1 over 2, 1 over 3, 1 over 5, 1 over 10, you have the same shape. Am I right, Jamaat? We have the same shape. Right to left, left to right. Did you understand? Can you sketch such a graph like that to 10 to power x, just do it. Good. What's the important things here? The important here is that generally speaking, intersection points. The important here is what? Is how to sketch. Look at the example number 4. So your test or your exam is look like that one. How? Because at the time, of course, I'm not give you 10 to power x. I'm going to give you to some with something. No sada, with a biryani, right? So how we solve that one? Yalla. You remember how to shift, right? How about if the addition is outside, inside? You remember that, I think. We have x squared, x plus 1, right? X inside plus, inside minus. So how we play with that one? So in the original, you know, the original function is what? Is y equal to 2 to power x. Am I right? This is the original. Clear. So I know the shape is like that. Now, we add inside or outside? We add 1 to inside or outside? Of course, outside. So I'm going to shift it to up. So I say if my graph is y1 to 2 to power x, I say is like that. So after adding 1 outside, is going to be where? Up or down or right or left? Up, of course. I have the same shape, but what's changed? Where's the change? Here I have what? 0 on. How about here? 0 and 2. How do you know? Because if I put 0 here, I'll get 2 to power 0. 2 to power 0, 1. 1 plus 1. So I got the result. Easy, right? How about minus 2? Exactly. Come to down. Shift to down. Do you have any question about the first? Dears? Good. Now, tell me about minus. So minus outside or inside? No, inside is like that. Here's inside. If I say inside, it should be like that. Understood? So how's the outside? Of course, if there's a outside the function. So I have 2 to power x. Look, to understand more, to give you more clue, I say y equal to 2 to power x. Now, y equal to 2 to power x multiplied by minus. So of course, it is outside. So how we solve the outside? Outside is what's the x-axis? We talk about swimming pool and mirror. Do you remember? So that one is what? Swimming pool. Understood? This is the original. That one. Okay. So tell me about the point. Is here where? 0 and minus. You are right. Put 0, you will get 2 to power 0 multiplied by minus 1. You go. So easy. Just need 2 things. Think about it. Where's the change? Put the 0 into x, you'll get a point. Right? Every time put the 0, you'll get a point. And of course, I'm going to leave that one for you. But just tell me, where's the intersection point? Just tell me the intersection point. C. If I put 0, look. If I put 0, I'll get what? Kaka. And 2 to power minus 1 means what?
Negative.
Negative what? Negative 2. 0.2. 0. Really? You must be joking. All of you. Is equal to why 0 point? It's 0.5 right now, but why 0.2? I don't know. You know, so we have a power minus negative will come to down, will be positive. Right? We did before that. We say, how about 2 minus x? And we do like that. So it's 1 over 2. So the intersection point you can see from here, from the C part, the intersection here is what? 0 and 1 over 2. You got it? So careful, the point is important. Do not forget about during the exam. Just make it 0, let x be 0, you'll get the result. Do you have any question about first part? It's very easy, very short. You need a graph, you need to play with the graph, you need an intersection point. Clear? Good. Now, how about the same thing? The same thing, but just I change small thing. Look, we have what? Natural exponential, which is symbolized by e. I say f of x equal to e to power x. The same, you can think about like a 4.1, the same thing like 2 to power x. Tell me about the shape of the graph. How was it? Yalla? Shape of the graph. The same. Where's the point? If I put 0, I say e to power 0 equal to what? Is number. E is a irrational number, and 2 power 0 is equal to 1. So I will get what? 0. Tell me about this function. Yalla, it's your turn. Is equal to what? How's the graph? Right to left or left to right? Yalla. Opposite in the other side. Tamam? Left to right. Did we change anything? No. How about if I say y equal to minus e to power x, like a previous one? I have minus 2 to power x. You remember? What did we do? Well, how's the intersection point? You got it? So the same things here is repeated, but instead of 2, we have e. Look. Don't forget again about example number 1 because it needs calculator. We don't use the calculator. So look at this example. Look, here's minus. We did before together. Tell me about the intersection point of here. Yalla. So now I have two things. 3e to power 0.5x. Yalla, tell me about the intersection point. Okay. Let x be 0. So 3. E to power 0, 1. 3 by 1, 1, 3. So the intersection point will be at 3 and 0 and 3. Clear, dears? Just make it 0. The same shape, but something changed because you multiply by 3. What's changed? A little bit in numbers. How we get that number? By making x to be 0. E to power 0 equal to 1. So 3 by 1, I'll get 3 by 1, I get 3. Hard? No. So try to study well with it. The first part, it was about exponential and the graph, right? So graph of two of them. Now graph of the others. We say we have 3 diagram, we have a 3 chart. So graph is very important. But graph of what? Exponential and logarithm. Now I'm going to log and len together. It's easy, the same but different. And the same strategy, we are going to use it, but different things. On example number 1 is again exclude because need to calculate. We don't care, but kindly do it at home to just because help you to deal with it in the other lectures. Good. Now, and this is the property. I'm going to talk about this one later. Okay, later I'm going to talk about that one. The important things, this property is very important. Let me start with that one. Then later I'm going to the graph. So I'm going to the graph first. Yalla. 4.3. logarithmic function. How about logarithmic function? We have f of x is equal to log of x. Yalla. What's the important? Graph. How's the graph? Opposite of your ln. Yeah, sorry, your exponential. Do you remember? Exponential, it was like that. But logarithmic, no, it's like something else. Tell me about this point. Yalla. 1 and 0, exactly. So I got that. Log of 1 equal to what? 0. That's why if I input 1, I'll get output 0, no change. Okay. So, you have a calculator or mobile? Okay, so kindly find log of -2 for me and give me the result. Yalla, let me see. You know how to use it or not? Yalla, log of -2. Find -2. 0.3? I don't know it. Undefined. What else? Error? Why? How about log of 0? Find log of 0 kindly. Error again. Why? Because exactly. So ln and log, careful, ln and log. We did it by practice. Ln or log, I'm going to talk about it later. Here shouldn't be 0 or negative. Why? Look at the graph. The graph, this is positive of x, means that in your calculator you can put the positive number. Till here, put ln of 1 or log of 1, you will get 0. Put log of 0.001. We are here, it's okay. You'll get negative part. But if you want to talk about 0, we cannot. Exactly. It's asymptote. You're right. Vertical asymptote. So we cannot put 0 or negative into ln. So do not forget about the graph. That's why I say try it here. Practice. Okay, dears? So now I have the things how to sketch them. Here's the sketch. Look at them. Log of 2, log for any base. Log for any base. 5x. The graph again is like that. Maybe your friend asks you about graph of log of 2x. I say as a shape is the same as a shape. Clear, dears? You shouldn't exceed the x-axis. Sorry, y-axis, because the canal, as he says, asymptote. Clear what I see? Cleared, Kaka? Good. Now, look at the graph. 4, 2, 4, 3, 4, 5, 4, 10, whatever you have, as a shape is like that. As a shape. Good. That's the first. So, for graph, this example are important. Why? Because I have negative, this is inside or outside, Jamaat? Outside. How about that one? Inside. Yalla, let me see what's going on. For outside, I have the original. Yalla. For outside, we change what to what? Y will change it, right? So this part will be like that. Am I right? We say outside means that swimming pool. X-axis is the mirror. How about the other part? That part is going to be what? Going to be like that. So generally, if I want to sketch this graph, part A, I see is like that. Did you understand? Shall I repeat it? Just make the mirror here and there. If it's in down, it's going to up. If it's in up, I mean above of the x-axis, will become to the under the x-axis. Clear, dears? Good. Then tell me about that minus. Yalla. Huh? Why need? Why no? How about minus 2? Right? If x is minus 2, I have what? Minus 2. So now you get 2. So it means that, hey, exists. Good. And I need your speech, but later. Thank you. Yalla. We say what's a mirror? Y-axis, right? Good. So y-axis will be the mirror. Look at here. This is the original. During the exam you should do. Then show me the second. I say because y-axis is the mirror, change it to the other side. So I'll get like that. Understood? I'm going to ask you some question. Can I put or can I substitute 0 here? No. Can I put positive numbers here? No. How about negative? Yes. That's why the graph is going to the other side, to be logic things. It's going to be, instead of being here for log of x with any base, I say what? I say my function will change to that side because cannot take a positive numbers. You got it there? That's why it's going to the other side. Good. And how about the graph of this? Yalla. Right? 2 units, 2 up. So I have a log like that. So tell me about, if I put 1, I will get what? 0. So 0 plus 2, I'll get to 2. So that's why the graph is like that. Maybe you ask me, why is going to up? Because we shifted to up by 2 units. You got the idea, dears? This is the original. I'm going to shift that one to up by 2 units. Understood? When log of 5 of 1, when I'm at 1, at point 1, I know log of 1 equal to 0. Then I'll get what? I'll get 2. So when x is 1, y is 2. That's why it's going to here. Clear, Kaka? Good. Any question? Okay, tell me about the second, yalla. Can you sketch the second? Kindly do it. Like a practice. Think about it and do it. Or at least imagine it. Yalla. Yalla, imagine it. How is it? Log x minus 3. If minus or positive or negative is inside the function, it's going to up, down, left and right. So by 3 units, come to the right. That's it. So I have this graph. Am I right? Y is at 4. Y is not at 3. Exactly. 1 plus 3, it will be what? 4. How about the asymptote? How about the asymptote? Also that one will shift. 0 plus 3, 3, right? 1 plus 3, 4. Easy. Just play with it. Do it at home again. Just 1 time, 2 times, sketch it, and you deal. You see it's easy, it's not such hard. Question about the function generally. No. Okay, now I'm going back to the properties. I'm going to talk about properties. Look, Kakajan. This one, guys, these properties can be shared with len, the same. So in there, we are not going to repeat it. The same. How? I'll tell you. Log of 1 with any basis, 2, 3, 10 is equal to what? 0. tamam. Any question? How about ln of 1? 0. Understood? Good. And second, log of AA equal to 1. What do you mean? Can you make the number? Yes. Log of 5 with the base 5 equal to 1. Understood? But here we have ln of E equal to 1. Careful. Why? Can you tell me why? Huh? Okay, but why is 1? Because, no, yes, you are right. Because log of E x, and what's the ln? Let me ask you about ln. What's the ln? Ln of x, generally, if you want to define, I see is a logarithmic, but with the base E. And we recalled as a ln. So that's why ln of E equal to log of E with E. And AA will give me what? 1. And you can say they are cancelling each other because they are inverse of each other, opposite of each other. The same thing. This is the second property. Do you have a problem? Number 3. Log and exponential are inverse. What do you mean? I say log of A of AX equal to X. Why? Because I say this is the function and this is another function. They are inverse. Do you remember the inverse will give you I? So that one will cancel that one. And I'll get what? X. Clear, dears? And the same thing is true if I have something like that. Again, that one will cancel the exponential and I'll get A. To understand, let me give you the number. I say 2 to power logarithm of 2 of 5x plus 2. I say this one will cancel with that one because this is the base 2 and the base 2. So I'll get 5x plus 2. Now I think it's more clear. Do you have any problem? How about log of 5x plus 2? Is equal to what? X plus 2. Tamam? This property, can be used, look at the examples, can be used whatever you like, whenever you need. So kindly try to solve that one. If you have a problem, you have a misunderstanding, give it back to me. Okay? Listen to the video. Try to study. If you see there's a difficulty, give it back to me or visit my office. Understood? Dears? No signal? Okay. We talked about graph. So I'm going to the ln. Property of the ln. Look at the ln. Wait. You saw that one before, right? You saw that one before, right? We see that one will that one cancel. And that one will cancel, will give you the same. Do you have any problem? Can you solve this example for me kindly? Yalla. Can you show me ln e to power 8 is equal to what? 8. Okay. How about that one? B. Yalla. Yes? B equal to what? Hello? Yes? No? No? Minus 2. How? I say ln of e to power minus 2. Am I right? Then they will cancel each other. I'll get minus 2. You can see. Clear, dears? C is cancelled because talking about calculators, I don't like it. Good. So try to solve the exercise 39 to be familiar with the identities more. Example number 10. Because of the Ramadan's month, we make the discount, so cancel. I was talking about domain, that's why. Any problem? Dears? Do you think it's hard? No. So, I know you are tired, but I need your patience for 4.4, then we will finish. Because they are collect. But 4.5, 4.5, we are going to use the property there and we are going to solve. It's not hard, but need a combination. Yalla. Tell me about this. Just translate this one for me. There. What do you see here? 3 importance rules for log and len. For log and len together. How? Because I can write down len AB equal to len A plus len B. And usually I make numbers or things in the parentheses, brackets. The same thing is true for here. Len of A over B equal to len A, exactly, minus len B. So I'm going to ask you, look at this one carefully and I'm going to ask you some question. Carefully, I mean 100% memorize it. Okay. So tell me about len of A plus B equal to what? Len of A multiply. This is the first answer. Any answer? Any other answer? Any other idea? جماعة ليه؟ len A plus len B. Okay. Where did you bring this rule? Yalla. Do you think we wrote something like that? Hello? So that's why I say capture it, memorize it. We don't have such thing like that. So len, listen to me, Kaka. It's a little bit tricky. Len can be distributed over multiplication. Len or log can be Aram, Kagar. Len be Quran or Aram? Which one? Len be distributed over, listen Kaka, listen, over division, but cannot be distributed over addition or subtraction. We have no such rule. Okay, so thank you for your invention, Yani, you make me unhappy. So we don't have something like that. Careful. The first. The second. Look and listen. If I have one log with one multiplication, I can separate it. I can, yes, to 2 log with addition. No. Come on. Where's Duja? Where's Jawazi? Okay. Understood? If I have one log with division, I can make it to the log, first log minus the second log. Then of course, vice versa also true. If I have 2 log, nobody say you are wrong. If you have 2 log, log A plus log B with any base, let me say 10, you can say is equal to log of AB, right? Because they are equal. 1 log multiplication is equal to 2 log with addition. Tamam? Clear? Good. So just take care about this rule. Do not make a kafir taboo. That's it. So you can control the properties. The third property, so the same thing is true for len. The third property, we have what? This is very important. Actually, you are going to use it later, especially in 4.5, which we needed. We have what? We have len or log with any base for BC. That one will come to down, and I will get the log of B with any base, 10 len. The same thing is true for len. Len of x to power 2 is equal to what? 2 len x. Yes. Clear? Understood here? 2 len of x. Yalla. Let me practice that one. Here's the practice, you can see. log base 8 minus 5. 80 minus 5. So I can say is equal to 80 over 5. Am I right? How about here? I can bring it to the power. I can bring it to up. Then I have minus 3. I can deal with it. That one is not neat. Do you have any problem? Can you do it, yalla, by your hands? Can you expand that? Is equal to log kaka mabisa. Because I have multiplication, I'm going to write addition plus. So 4 6 4x. Tamam? How about the second? Not just the same. We can follow 2 or 3 rules. How? This is equal to log of 5x cubed plus log of 5y to power 6. Do you have any problem? Then use the third rule. How? Bring this one to down. I say expand, simplify. So I'll get what? 3 log, 6 log. Kindly do not touch the base. Kaka. Do not touch the base. You cannot touch the base. How about ln? The same. Ln AB minus ln cubic root of C. Am I right? Do you have any idea, other idea, any step? Ln A plus ln B by the first rule. How about that one? C cube means what, Kaka? C square root means that C 1 over 3. Then I have a ln, so I say 1 C. It's not hard, but need work. A little bit is tricky. Now, يلا دي. Look at Kakajan. عكس يبيو شو أخذوا أخو يعني actually we don't talk about atom. You just expand, take it يعني just rule. Take جماعة. Now combine is the reverse operation for the previous one. Expand, combine. يلا ده combine كده. Am I right? I'll get what? Plus. Do you have any problem? So tell me about the next. Next of this step. What else? Right? We have log. We have log. We have addition. They are the same base. So we make it a multiplication. Right? How about this example day? Do it by yourself. It's easy. Please try it. If you try here, you don't need to study at home. Really. Yalla day. Yalla, combine Yoka. Combine this. They together. First line. They first line. Ln of or yeah, it'll be far. You are right. Tamam? It was hard? No. Now, between addition, make a multiplication. I'll get what? Am I right? And between subtraction, make a division. Oh. has two rules. Just play with it. It's not something to think about it. And this means that don't do kufr. We saw that on taboo is you cannot do it. Is the caution, is warning. And we say that. Let me see what's going on here. Only one rule remains. Only one rule. Yalla. What do you mean by that? AX, BX. What do you mean by that? Means that, for example, if you have a table of log of 10, during the exam, if I give you, for example, table of the, I say find log of 2 by 5. But you know about just log of 10. So you say is equal to log of 5, 2 with the base 10 with the base 10. Understood what I say? If you have a catalog, give you log of 2. And I say find this one for me. You say what? You say log of 2 to 7, you're log of 8 to 2. You got it? Maybe your keyboard is not working nicely. Huh? When number 2 is not working, you can use another number. And you'll get the same. You'll get the same result. That's all about how to use this property. Thank you for listening. And that's enough for today. Let me give you time to take a rest.